So today we will discuss chapter 4, chapter 4, soil soil compaction. Yeah. Engineering service exam PYQ previous year question. Chapter 4. This is question number 1. For conducting a standard Proctor compaction test, the weight of hammer P in kg, the fall of hammer Q in mm, the number of blows per layer is R, and the number of layers is required are respectively. So in a standard Proctor test, um, the number of layer is 25. Number of layer is 25. So this and this may be the answer. And sorry, number of layer is 3. Okay, number of layer is 3. So this may be the answer. And number of blows is 25. So this and the weight of hammer is around 2.495. 2.495 is very close to 2.60. So answer will be D. So in this type of question, for solving this type of question, I am giving you a table. Just remember this table. Okay. Just remember this table. You can solve this problem according to this table. Okay. So let me make the table first. So this is weight of hammer of hammer weight of hammer. Second is uh, fall of hammer, fall of hammer, fall of hammer in mm. Third is number of blows per layer, number of blows per layer per layer, number of blows per layer, and volume of mold. Fourth is volume of mold, volume of mold in cc, centimeter cube. And fifth one is energy point volume, energy per unit volume, energy point volume. Okay. So and there are many tests. The first is a standard Proctor test, standard standard Proctor test. Second is modified Proctor test, modified Proctor test, modified Proctor test. Fourth is um, light compaction test, light compaction test, and fourth is heavy compaction test, heavy compaction test. And these two tests are Indian standard equivalent, Indian standard equivalent, equivalent of Proctor test, of Proctor test. Okay. So very important table. Just remember these values. Okay. You will be able to do all the question related to Proctor tests. Yeah. Weight of hammer is, in case of a standard Proctor test, it will be 2.495, 2.495 kg. And in modified Proctor test, it is 4.54 kg. 4.54 kg. And in light compaction test, it will be 2.6 kg. 2.6 kg. And heavy compaction test, it is 4.9 kg. 4.9 kg. Okay. This light compaction test and heavy compaction test, it is Indian standard equivalent of Proctor test. Okay. And the fall of hammer, in case of a standard Proctor test, it will be 304.8 mm. And in case of modified Proctor test, it will be 457.2. 457.2. And in case of a light compaction test, it will be 310 mm. And in heavy compaction test, it will be 450 mm. And number of blows for all the test, it will be 25 number of blows per layer. Okay, number of blows per layer is 25. Okay, and uh, number of layers in a standard Proctor test, it will be 3, and in modified Proctor test, it will be 5. And similarly, in light compaction test, the number of layer will be 3, and in heavy compaction test, it will be 5. And energy point volume is given by formula energy point volume E is equal to capital N, that is number of layer, small n, number of blows per layer, and W is the weight, that is m into g. This mass into g is weight, and h is height of fall divided by volume, volume of volume of mold V. So this will give you the uh, energy per unit volume. So in case of a standard Proctor test, energy point volume will be 594.29, and in this case modified Proctor test will be 2696.31. Okay, and in case of light compaction test, it will be 593.014. And in case of heavy compaction test, it will be 2703.88. So in this case, this is in this question, uh, a standard Proctor compaction test, a standard Proctor compaction test. So this will be asked about this standard Proctor test will be asked. So weight is 2.495, 495 kg, and height of fall 304, 25 and 3. So D option is very close to this. So answer will be D. Okay. So now second question. Let me discuss second question. Second question is, sieve foot roller are recommended for compacting. Sieve foot roller are recommended for compacting cohesive soil actually. So cohesive soil will be the answer. Second, 2. Okay. So let me discuss a table for this type of question. Okay. And this question is frequently asked in engineering service examination. So let me discuss the table related to this question. Okay. So suitability suitability of compaction equipment. Suitability of compaction equipment. Suitability of Suitability of compaction equipment. So first is I'm writing here, first type of type of equipment. Type of equipment. And this column, that is suitability for soil type. Suitability for soil type. Soil type. And the third column is about nature of project. Nature of project. Nature of project. The first is rammer or tampers. Type of equipment. First type of equipment is rammers or tamper. Rammers or tampers. Rammers or tampers. And suitability, all type of soil. It is suitable for all soil. It is suitable for all soil. And the nature of project in which rammer or tampers used, that is in confined areas, in in confined 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 areas such as fields fields behind retaining wall, behind retaining wall, retaining walls, comma, basement basement walls, etc., etc. Okay. Now the next equipment is smooth wheeled roller. Next equipment is smooth smooth wheel roller. And suitability for soil type is crushed rock, gravel or sand. Crushed rock, gravel, gravel and sands. And type of project, that is road construction, etc. Road cons- road construction, etc. Okay. The next type of equipment is pneumatic tired roller. Pneumatic pneumatic tired roller. Pneumatic tired rollers. And the suitability for soil type is sand, gravel, this is common. Sand, gravel, silts, clay clay soil, not suitable for uniformly graded soil, not suitable for uniformly uniformly graded graded soil. Okay. And the nature of project is base, subbase, subbase, and embankments. And in bank embankment, compaction, compaction, embankment compaction for highways, for highways, airfield, air airfields, etc. Earth dam, etc. Earth dam, etc. Okay. Now next equipment is sieve foot roller. Sieve foot roller. Sieve sieve foot foot rollers. Sieve foot rollers. And type of soil is clay soil. Clay soil. So in this question, this is asked. So answer will be B, clay soil. Okay. And it is suitable in project like core of earth dam, core of earth dam, core of earth dams. Okay. And next one is vibratory roller. Vibratory rollers. This is suitable for sandy soils. This is suitable for sands. And the type of project is embankments, embankments for soil, for oil, embankments for oil storage tanks, oil storage tanks, etc. Okay, so this is the table. You must remember this table for solving this type of question. And this question is frequently asked in engineering service examinations. Okay, so very important table. We will discuss this again and again because this question is asked again and again in engineering service examination. So every time I will discuss in form of tables or in form of paragraphs. Okay, and because this is very important. Okay, in ESE examination, this type of question is frequently asked. So this is all about question number 2. Okay, now we will discuss question number 3. Question number 3. Permeability continues to decrease with the increase in dry density of a compacted soil. This is assertion, and the reason is soil particles in water surroundings may be mutually attracted or uh, repulsed. Okay, so the answer for this question, both statement is true, but reason is not the correct explanation of assertion. So for this question, answer will be B. Answer will be B. Answer will be B. So let me discuss this question in form of graphs. Okay. So as dry density increases, as dry density, as dry density increases, soil particle come close. Soil's particle, soil particles, soil particles come close, come close, and therefore wide ratio decreases, and therefore wide ratio wide ratio decreases. Okay, if we plot the graph between dry density and dry density and water content, then it will be look like this. This is on x-axis, it is water content, and on y-axis, this is gamma dry density. Okay, and if we draw the graph, we'll find the graph will look like this. Okay, so here at this moisture content, this moisture content is called optimum moisture content, OMC, optimum moisture content. Okay, OMC, that is OMC, that is optimum moisture content, at which the dry density will maximum. This is gamma D max. Okay, and if we draw a graph uh, of, I'm taking this line as gamma D, and this is this line as permeability K. Okay? If this is K, that is permeability. If K, this is permeability, and on this axis gamma D. So for where gamma D is maximum, where gamma D is maximum at this line, gamma D is for this water content, gamma D is maximum. So the permeability will be minimum. So as gamma D increases, the permeability goes on decreasing. The permeability goes on decreasing. Okay, so permeability goes on decreasing up to this point. Up to this point, permeability goes on decreasing up to this point because gamma D is increasing. And when gamma D start decreasing, okay, gamma D start decreasing, the permeability will be permeability will increase from this point. Okay, so graph will look like this. Okay, so the assertion is permeability continues to decrease with increase in dry density. Yes, this is correct. Permeability continues to decrease when dry density increases. Okay, and the reason is soil particle in water surrounding may be mutually attracted or repelled. Yes, reason is correct. So let me discuss the reason or why it is so. So soil soil particle, soil particle in water, soil particle in water surrounding, soil particle in water surroundings, soil particles in water surrounding may be mutually, may be, may be mutually attracted, may be mutually attracted if the surrounding, if the if the surrounding is dry side of optimum, if the surrounding is dry side of dry side of optimum, dry side of optimum, this is this region before OMC, this region is called dry side of optimum. This region is called, this region is called dry side of optimum, dry side of optimum, and this region is called wet side of optimum. This region is called wet side of optimum. And in this, and on this side, the structure of soil is dispersed, dispersed, dispersed structure, dispersed structure forms. Okay, or in this side, flocculent structure. Flocculent structure is on this side. Flocculent structure is formed. Okay, and this is dry side. Flocculent structure is formed, and attraction will be predominant. And attraction attraction predominates. And attraction predominates. And in this side, the repulsion predominate. Repulsion pre repulsion predominates. So this explanation I am writing in paragraphs. So soil particle in water surrounding may be mutually attracted if the surrounding is dry side of optimum. Okay, surrounding is dry side of optimum, and flocculent structure is formed, and flocculent and flocculent structure is formed, and flocculent structure is formed. Okay, and it may be mutually repelled, and it may be mutually repelled, it may be mutually repulsive, it may be mutually repulsive, it may be mutually repulsive if surrounding is wet side of optimum. If surrounding is wet side of optimum, wet side of optimum, and in this case, and in this case, dispersed structure is formed. Dispersed structure is dispersed structure is formed. Hence, reason is correct. Hence, reason is correct. But it is not the correct explanation of assertion. Okay. So this is all about question number 3. Hope you understand. Okay. This is question number 3. Now we will discuss question number 4. Now we will discuss question number 4. This is question number 4. Consider the following statements. Relative compaction is not the same as relative density. Yes, this is correct statement because this is statement 1. Relative compaction. Relative compaction. Uh, relative relative compaction is equal to gamma d filled, gamma dry filled by gamma d lab, gamma d obtained in lab, and gamma d uh, achieved at field. The ratio of these two quantity is relative compaction, and it will always be greater than 0, never equal to 0. Okay, but the relative density, but the relative relative density is equal to wide ratio, maximum wide ratio minus the wide ratio in field divided by maximum wide ratio minus minimum wide ratio, and it may be 0, and it may be 0 also, 0 also. So these two quantity are not the same. So statement 1 is true. Statement 2, vibroflotation is not effective in case of highly cohesive soils. So uh, is this statement is also this statement is also uh, true. Okay, because vibroplotation is not effective in case of highly cohesive soil. It is effective in case of sandy soils, vibroplotation. So, what is vibroplotation? Let me discuss first what is vibroplotation. Okay, so vibroplotation, 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 vibroplotation. Vibroplotations used a vibratory probe. Vibroplotation uses a vibratory probe, vibratory probe, and water jetting to settle soil and water jetting to settle soil to settle soil